Good morning, everyone. Today we're going to talk about parallel lines and transversals while the rest of the class takes their test at school. So parallel lines, we have a symbol for those. It looks like this. Parallel lines never intersect and they are on the same plane. Skew lines, hold on, an example from the picture. I'll use this picture down here, okay, for some examples. An example of parallel lines in this picture could be AB and CD. They're on the same plane and they're parallel. They're never going to intersect. They keep going in this direction. So AB and line CD is an example of parallel lines. Skew lines are lines that do not intersect and are also not on the same plane. So an example from this picture of skew lines could be AB. Here's AB. And CG or GH. Both of those are skew to AB. They never intersect, so this, if it kept going, is never going to hit here. It's never going to intersect, and same with GH. It's going this way. It's never going to even come close to that, and they're not on the same plane. So this line is on these two planes. This line is on this top plane. This line is on the bottom plane. So the two lines do not intersect, and they are not on the same plane. Parallel planes are planes that will never intersect. So an example of a parallel plane could be this top plane and this bottom plane. So I could call the top plane ACB and the bottom plane, I could call it EGF. There are a lot of parallel planes in this picture. There's also these two side ones in the front and back. Name all planes that are parallel to plane ABC. So plane ABC is at the top. We actually just did that. Plane parallel to it would be EGF. It's bottom one. Name all segments that intersect AB. So AB is right here. So any segment that runs into it, that touches it. So AE does. Basically any segment you can name that has A in it or B in it. So AE does, AC does, BD does, and BF right here. So all of those segments run into AB. Name all segments that are parallel to HG. So here's HG. We can say that CD is parallel to it. We could also say that AB is parallel to it. And we can also say EF. They're never going to intersect and they are parallel. So this is parallel on the bottom plane, side plane, okay? Actually, so parallel lines have to be on the same plane. So is AB on the same plane as HG? It's actually not. So we actually can't say AB. We can only say CD and EF. AB would actually be skew. Okay. Name all segments that are skew to DH. So DH is right here. So any segment, we want any segment that does not intersect and is not on the same plane. So these intersect. We can't use those. We can't use this. We can't use that. We want ones that are not on the same plane and do not intersect. So we could use AE. It's not on the same plane. It's definitely not going to intersect. We could use EG, AC. AB does not look like it will intersect. We could use EF. That looks like about it. So we use this. We could, CD is parallel. CG is parallel to this, and it's on the same plane. We can't use that. These intersect, can't use that. This intersects, so we can't use that. This intersects, so we cannot use that. This is on the same plane and it's parallel, so we can't use that. So we've pretty much exhausted our options here. So we used A, B, E, F, A, E, A, C, and E, G. So those are all skew because they do not intersect and they're not on the same plane. Next up is our transversal. It's a line that intersects two or more other lines in different points. An example of what this could look like is a line like this. If I call this A, B, and L, L would be an example of a transversal. So it's intersecting two or more other lines at different points. Here's the two different points that it's intersecting at. Okay. I'm going to flip over, and now we are going to talk about when a transversal intersects lines, these specific angles are formed. I'm going to use my highlighter and a different color pencil and pen here just to kind of show you these angles. And you are going to have to memorize these angles. So first we have our exterior angles, which are angles on the outside of the two lines. So these are my two, this T is my transversal, and these are my two lines. So I want the angles that are exterior that are outside of these two lines. So these are exterior and these are exterior. Okay. Once again, T is my transversal. I want the interior angles now. So any of the angles that are inside those two lines. So example here would be 3, 4, 5, and 6. Those are our interior angles. So when I say interior, I think of inside. When I think of exterior, I think of outside. And we're talking about these two lines. Is it inside the two lines or outside? So these values are inside, these angles are outside. Consecutive interior. Consecutive means one right after the other. And then we know that interior means inside. Okay, so consecutive means one right after the other, like 3 and 4. Those numbers are consecutive numbers. So consecutive interior angles here, we want to just focus on the interior. So we're just looking at 3, 4, 5, 6. These would be an example of consecutive interior. So an example would be 3 and angle 5. Another example would be 4 and 6. And you see that I'm color coding here because if I circle all of them, they'll just look like they're all interior again. And you will have to memorize these words. So all of these terms at the top are important. Alternate exterior angles. Alternate means they're on different sides. I was going to write it, but it's already there. Alternate means they're on different sides of the transversal. So if you alternate with somebody in a sport, then you switch in and out with them. So in basketball, somebody might be your alternate. That means you switch out, you sub in and out for each other. So you're on opposite times. You're doing things on opposite team or opposite time. So in math, it's opposite sides. So we're on different sides of the transversal if it's alternate, and they're both exterior. Okay, so alternate exterior example would be 1 and 8. They're both exterior and they're both on opposite sides of the transversal. Another example here would be 2 and 7. The next one is alternate interior, very similar. Alternate means we're on different sides, but interior means we are inside. So now 3 and 6 would be an example. And my other example would be 4 and 5. So that word interior tells me I'm talking about inside angles, but alternate tells me they're on opposite sides. And last but not least, we have corresponding angles, which are probably the trickiest. They're on the same side of the transversal. So that means these 1, 3, 5, 7, those are all on the same side. 2, 4, 6, 8, those are all on the same side. So they're on the same side. One's interior though, and one is exterior. So 1 and 5 would be an example. There's actually 4 examples here. 1 and 5 would be an example. Also 3 and 7. One's outside, one's inside. Also 2 and 6. And last but not least, we could also do 4 and 8. Okay. Now, and there is a relationship between these with their actual angle measures, but we'll get to that next class. So let's think about some problems that we might see in regards to these. Identify the transversal that forms each pair. Okay, so 1 and 9. What transversal are they on? They're on this one, N. 9 and 15 are on this transversal, Q. 4 and 6 are on P. 7 and 16 are on L. 12 and 14 are on Q. Okay, so 12 and 14 are on 2 different lines, but they're on the same transversal. Identify the special name for each angle pair. So first we have 3 and 5. There are a lot of different things going on here. So there's one transversal, but there are 3 different lines, so it gets kind of confusing. So I like to cover this one up so I can see better. You can see here that these are my 2 lines. One is exterior, one is interior, and they're on the same side. So when I go back over here, I'm looking for something on the same side, so not alternate. And I'm looking for one interior, one exterior. This is interior, so it can't be that. So it's going to be corresponding. Six and 12. Here's 6. Here's 12. I'm going to cover up that middle line to make this easier to look at. These are my 2 lines. They're both exterior, and they're on opposite sides. So that's going to be alternate. That's what it means when they're on opposite sides. And exterior, because they're on the outside of the 2 lines. I have 4 and 8. If I cover up this top line, 4 and 8 are both inside these 2 lines, and they're on opposite sides. So that would be alternate interior. 2 and 3, if I cover up my bottom line, 2 and 3 are on the same side, and they're inside. So that would be consecutive interior. Sometimes you'll hear people say same side interior instead of consecutive. That's okay too. 8 and 12. So I'm going to cover up this middle line. 8 is on the inside of these 2 lines, and 12 is on the outside, and they're on the same side. So that's going to be corresponding. 5 and 9. If I cover up the top, they're both interior, and they're on opposite sides. So opposite sides tells me I'm using the word alternate, and they're interior. 4 and 10, we're throwing it back here to an angle relationship that we've already talked about and are being tested on right now. These are just vertical angles. So basically, this is kind of a hint. Don't forget, in both of these, you can't forget about the basic angle relationships that we've learned. So 6 and 7 is another basic relationship. Those are a linear pair. They are on a straight line together. All right, so you guys are going to do some practice on this today just to get started. Make sure that if you haven't taken the test yet, you are still studying today. If you have taken the test, you can just focus completely on this new material. All right, have a great day, guys.